were a couple problems in the homework where we have logs with different bases. And we talked before about how we can't use our properties of logs. We can't use the product property, we can't use the quotient property. If you use the power property, you can still drop an exponent down in front or go the other way. The other thing that you can do when logs are different bases is we are allowed to use the change of base property. So looking at what's labeled up here as number 13. If we were going to go about changing the base so that we could use our product property, what base do you think we should change it to? 125? We could do 125. It's a smaller base than 125. I like the base of 5. We could do the base of 125, but I like the base of 5 because 25 is a power of 5. And 125 is a power of 5. So here's how I might go about doing this. Leave the first one alone, because that's already base 5. Log base 5 of x. Plus, and then if I change this to be log base 5. What would go up in the numerator? Log base 5 of x would be in my numerator. Log base 5 of what would be in my denominator? 25. Because remember, when we change the base, the argument goes up in the numerator. And the original base goes down in that denominator. Plus, and now let's change this base also. Log base 5 on the top. Log base 5 on the bottom. What would the argument be up in the numerator? X, and in the denominator, it's 125. 222. Does anybody see anything that I can do with those denominators now? I can simplify these denominators. Log base 5 of 25 simplifies to what? 2. So up in the numerator, I have log base 5 of x. And in my denominator, I have a 2. What about for that third term over there? 3. So log base 5 of x over 3 equals 2. Well, instead of writing it over 2, why don't I just write that as 1/2 log base 5 of x plus 1/3 log base 5 of x. What can I make use of now that I didn't see at first? I can make use of the powers property. X to the 1/2, that would be the square root of x, right? And x to the 1/3, that would be the cube root of x. So log base 5 of x plus log base 5 of the square root of x plus log base 5 of the cube root of x. Equals 2. And now what can I do? Now I can do my product property. I have all the same bases on my logs, and they are being added together. So we can write this as log base 5 of x times the square root of x times the cube root of x equals 2. What do we do with the powers when I'm multiplying the same base together? We add them. So this is x to the first times x to the 1/2 times x to the 1/3. I need to add those together. So I'm going to need a common denominator. What should that common denominator be? 6. So x to the 6 over 6 times x to the 3 over 6 times x to the 2 over 6. What do I get when I add those together? How much? It's 6 plus 3 plus 2. 11. Okay, so I have log base 5 of x to the 11 over 6 equals 2. Where to from there? Rewrite in exponential form. 5 squared equals x to the 11 over 6. 5 squared is 25. How can I get rid of this? How can I get rid of that denominator of 6? What can I do to both sides? Raise them to the 6th power. I'm going to raise this side to the 6th power. I'm going to raise this side to the 6th power. That will cancel that out. I'm just doing my work up around here. So I have 25 to the 6th power, which I'm going to leave like that instead of putting it into my calculator. And x to the 11th. How do I undo this now? Do the 11th root. So x is equal to the 11th root of 25 to the 6th power, which I then could put into my calculator. But here it is in its exact form. So using a really similar idea, on number 14, how do I deal with the fact that I have two different bases here? Change the base, change it to base what? Change it to base 2. So log base 2 of x plus 6 over log base 2 of 4, which is going to become what then? 2. So I've got a 1/2 there. So 1/2 log base 2 of x plus 6 minus log base 2 of x equals 0. Log base 2 of the square root of x plus 6 minus log base 2 of x. What property can I take advantage of here now? Quotient property. I'm going to have the square root of x plus 6 over x, all with the log base 2 in front, equals 0. Where to from here now? Rewrite 2 to the 0 power equals the square root of x plus 6 over x. Multiply both sides by x here. I get x equals the square root of x plus 6. Square both sides to get rid of that 1/2 power, that square root. So x squared equals x plus 6. I can set this equal to 0 now by doing x squared minus x minus 6 equals 0. How will that factor? X minus 3 and x plus 2 equals 0. So x equals 3. X equals -2. Do both answers stand? No, which one does not? -2. But x equals 3 is a valid solution here. Did I need to check that this one was valid? I mean, I needed to check, but how did I know it was valid? It was positive, and all of these arguments are just x. So we're good there. So if you were stuck on any of those particular problems from the homework, hopefully that helped a little bit, the ones that have different bases. What do you guys want to see or talk about from the review? Yes. 1B, absolutely. Did you have a question for Brian or just read it? Number 1, part B, what type of function is this? This is absolutely fine. And what does an absolute value function look like? Looks like a V. I might not know exactly where it is, but I know it has this kind of a shape to it, right? Will that pass both the vertical and the horizontal line test? No. So is it 1-to-1? No. Not 1-to-1. It passes the vertical line test, but it fails the horizontal. It has to pass both of them if we're looking at it graphically. What else would you guys like to see? 2B. Or not 2B. I'm going to change this to a Y, and then my first step, I'm going to switch X and Y. I already know that my domain is all real numbers, so it's defined for every value of the domain because it's an exponential function, and by definition, the domain of all exponential functions is all real numbers. And so I switch my X and my Y. And now I need to solve for Y. I need to get Y alone. Where is Y right now? In the exponent. What tool do we have to isolate exponents? Logs. So I'm going to rewrite this as a log. So this will be log base 3 of my argument X equals my exponent of Y plus 2. Back 2 from both sides. So log base 3 of my argument X inside parentheses and then minus 2, because that minus 2 is not happening to the X. It's happening to the log base 3 of X equals Y. And then the very last thing I need to do. Oh, it's like without actually finding the inverse. I didn't read the directions very carefully. Sorry about that. Let me write down what the inverse is, and then I'll talk about how we find the domain and range without actually finding the inverse. I am so sorry. It doesn't help when I'm all zoomed in and not reading my directions. F inverse of X equals log base 3 of X minus 2. Okay. So original function. Domain and range. Domain for my original, all real numbers, negative infinity to positive infinity. For my range, positive infinity, negative infinity. What has happened to this? What has happened to our parent function? It's gone to the left. Sorry, I did that to the right. It's gone to the left 2. Does that affect its height up or down? No. So my range would be what? What is the lowest value for parent exponential like this? 0, 2. And then what would the highest be? Infinity. Right, so there's my domain and my range for my original function. For the inverse, domain and range. We said that this one had been shifted left 2. Oh, I put my parentheses in the wrong spot down there. I apologize. There we go. For logarithmic functions, which are the inverse of exponentials, my domain becomes my range becomes my domain. So I'm going to take the domain of range of the original one, and I'm going to switch them around. So from 0 to infinity would be my domain. My range would be negative infinity, positive infinity. So you can just set it down right there. Since I didn't read the directions fully and I did go ahead and find the inverse, let's check that against what we know. How has this been shifted from the parent? How has this been shifted from the parent? This one went left 2, but this one is going down 2. If it was inside the parentheses, it would be to the right 2, but it's not inside the parentheses. I wrote it wrong the first time. Sorry about that. It's been shifted down 2, but think about what a logarithmic function looks like. It starts low and then it curves. It has a range of all real numbers. Yes, sir. Why is there a bracket? Oh, thank you. The three parentheses, you're absolutely correct. It does not ever actually arrive there. Yes, sir. Yes, it should be H inverse. Right there when I write my inverse function, I think right. Because we started off with H. You're absolutely correct. Whenever it says without actually finding the inverse, you want to find the domain and range of the function that it gave you, and then switch those around, because for an inverse, the domain and range of the original function will be switched in the inverse function. Yes, ma'am. Absolutely. Let's do that one without finding the inverse first. Let's talk about domain and range for this guy. Domain, am I talking about x's and y's, x's or y's for my domain? X's. So if I'm talking about x's for my domain, I want to know anything that x could not be, anything that x is not allowed to be. X cannot be -3. So my domain is every other value for x, okay. Yeah. From negative infinity to -3, union, -3 to infinity. So because I know the domain of the original function, I now know the range of the inverse. Negative infinity to -3, union, -3 to infinity. You remember what we did in our rational unit? We have a vertical asymptote at x equals -3. Will this have a horizontal or a slant asymptote? Horizontal. How do we know? Yes, we have equal degree, top and bottom. It's not bottom heavy, it's not top heavy. The only way we end up with a slant asymptote is if it's top heavy. So here, my horizontal asymptote would be y equals 1x over 1x, so y equals 1. So my range, negative infinity to 1, union 1 to infinity. And as soon as I know the range of the original function, I know the domain of the inverse. Negative infinity to 1, union 1 to infinity. Yes, ma'am. So on a rational function, domain, well, and this is true for all of my domains, domain tells me the things that x is allowed to be. Since I have a denominator, I know that denominator is not allowed to be 0. So anything that would make the denominator 0, I have to cut out. Other than that, there are no other rules that would be violated here. Looking at my range, I want to look at all the possible outputs. So you can even think about doing something like this with, say, synthetic division or long division to figure out where that horizontal asymptote would be. But when you do long division, you take this piece on the bottom and you say, how many times does this go into the piece at the top? The answer is it would go in 1 time. X goes into X 1 time. That makes sense? So when we are equal degree top and bottom, those X's, if I were to take X and say how many times does X go into 1X, it goes in 1 time. So it's going to be the ratio of those leading coefficients when I have an equal degree. Yes, sir.
How would you like to explore
How would you do it with a slant asymptote? Long story short is on a question like this, without actually graphing it, you can't tell based because remember we had some with slant asymptote where we had a range of all real numbers and some where we had this gap because it was fitting into those little pi wedges. You can't tell that without actually graphing it. So if I were going to ask you to do something like that, it would have a whole problem with graphing. That would be more like a final exam question than a question for this particular unit that's just focused on inverses and mostly. Good question so far. What else would you guys like to look at? Let's see. Number 3. Find the inverse of each of the following. There we go. Do you guys need to see part B since I actually walked through finding the inverse on one of those? I could do part B again. Let's start with part A though. Finding the inverse. So I'm going to switch my X and my Y. It's going to be X equals 3Y plus 1 over Y minus 2. Multiply by the denominator, Y minus 2 on both sides. Most people on that first quiz where I asked you to do a similar problem to this made it this far without a whole lot of problems, and then we got stuck. I'm going to distribute this X. So I have XY minus 2X equals 3Y plus 1. The goal is to isolate what? Y. I had Y on just one side over here, but it's top and bottom, and I don't want that. So that's why we multiplied by the denominator. But now I have Y on both sides, and I don't want it on both sides because I'm trying to isolate it. I want it on the same sides. So I can subtract XY from both sides. And I'm going to go ahead and add 1, or sorry, subtract 1 from both sides at the same time. So that make that cancel. So negative 2x minus 1 equals 3y minus xy. My goal is that every term on the left-hand side has a y. That's why I subtracted the 1 from both sides, because the 1 didn't have a y with it. Now I can factor out that y. I have 3 minus x here. Now I can divide both sides. Negative 2x minus 1 over 3 minus x equals y times 3 minus x over 3 minus x. So, not 3x times 3 minus x. There we go. So my inverse function, f inverse of x equals negative 2x minus 1 over 3 minus x. And then we need the domain and the range of the inverse. So for my domain, I want everything that x is not allowed to be. Positive 3, negative infinity to 3, union 3 to infinity. For my range, I really should rewrite that denominator as negative x plus 3 to make this lined up more correctly. So I would have negative x over negative 2x, positive 2. So my range, negative infinity to 2, union 2 to infinity. Let's do part B now. Which my x and my y. So x equals 2 to the power of y minus 7. What tool do I have to isolate exponents? Logs. Let's rewrite this as a log. Log base what? Log base 2 of x equals y minus 7. I'm going to add 7 to both sides to isolate y. Then I can write my inverse. H inverse of x equals log base 2 of x plus 7. Domain. What would I be allowed to use for x there? All positive numbers. So everything strictly larger than 0 up to infinity. What would my range be here? What are the possible outputs? All real numbers. What other problems would you guys like? What else would you guys like to see? Yes, sir. 4B. Yes. All right. So we want to evaluate this. Log base 2 of 1 over 16. How would that evaluate? Negative 4. Minus 4 times log base 4 of 16 would be how much? 2. Plus, what would that one be? 1/3. This guy right here, that is 1/3 natural log of e. So this whole thing would simplify to just be 1/3. So I have negative 4 minus 8 plus 1/3. So negative 12 plus 1/3. The negative 11 and 2/3. So right about 10 more minutes. Well, because I'll continue working. 7B, absolutely. When I condense this guy into a single logarithmic expression, we have the same base on all of our logs. I'm gonna use my powers property here. Log base 3, I'm gonna write this as x to the 1/3 for right now. Plus log base 3 of 9x whole quantity squared minus log base 3 of 9 to the 1/4 power. 9x whole quantity squared would be what? 81x squared. I'm gonna go ahead and use my product property. So I have x to the 1/3 times, I'm gonna write this for right now as 9 squared x squared times 9 to the 1/4. And I wrote it as 9 squared x squared so that I could combine those like bases there. Because what will I do with these exponents? I'm gonna add those. So that would be 9 to the 9/4. Sorry, I forgot my log base 3 here. Log base 3 of 9 to the 9/4. X to the 1. It'd be 6 7/3. Is that correct?
Well, why would, hang on, there are both 9 different factors in.
Oh, thank you. I missed that subtraction. Thank you. I was just thinking plus here. Thank you for correcting me. Over 9 to the 1/4. There we go. Log base 3. X to the 7/3. 9 to what power now? I'm subtracting those exponents. 7/4. There we go. You could leave it like this as a single condensed expression, or you can write log base 3 cubed root of x 4th root of 9 all to the 7th power, since they share those numerators. Either one of those would be correct. Thank you for catching that. So we're, I'm sorry, yes. 7/4. So I'm going to subtract these two. 2 minus 1/4. So I have to change this. So that would be 8/4 minus 1/4. So that's how I got my 7/4. The x's are on the same side, so you add those. So with these powers of x here, because they're both in the numerator there, they're both on the same side of the fraction. We're doing 1/3 plus 2. So 1/3 plus 6/3. Which one? 6G. So for a problem like 6G, where I have two different exponential bases, we're gonna have to take a log of both sides. You can choose common log or natural log. You just want to choose one of the logs that's on your calculator. We're gonna do it to both sides. And once we do that, then we can use our powers property to drop these exponents down in front. That is a property specific to logs, so I can't do that unless I have a log. Then I would need to distribute this log of 3. So I'd have common log of 3 minus 2x. Common log of 3 equals x. Common log of 4. I want my x's on the same side so that I'm going to be able to factor them out. So I'm going to add 2x common log of 3 to both sides. Remember, I cannot combine that with that x common log of 4. I can just write it out longhand. So x common log of 4 plus 2x common log of 3. Have x's on both spots here so I can factor that x out. So common log of 4 plus 2 common log of 3 with my x factored out equals the common log of 3. And then I can divide both sides by what's inside parentheses. So what I would put into my calculator would be common log of 3 over common log of 4 plus 2 common log of 3. Number 9 and number 10, I did want to look at real briefly with you guys, just because there was a couple consistent questions coming up yesterday. The point that I want to show you is with question 10, but I want to use question number 9 to show you why this is happening. What formula would I use on number 9? PERT. It says it's compounding continuously, so A PERT. I'm not going to solve this one all the way out, but I want to get it set up and I want to do the first step so that it can make some sense on number 10 here. Where would that 2,500 go? That goes in for P. They give us our rate 0.0125. The power of t, because I take this and divide it by 100 to get my R value. What goes in for A? Why? Because the investment is going to double. Double 2,500 is equal to 5,000. What's our first step on this now if we're trying to solve for t? Divide by 2,500. And so then what would I have on the left if I divide by 2,500? 2 equals e to 0.0125 t. I'm going to pause right there. What did we want the money to do? Double. What happened when I divided by that initial amount? I got a 2, which is double. Down here on number 10, they don't give me a starting amount. They just ask me, how long would it take for the population to triple? I'm going to have a 3 right there. Because it doesn't matter what the starting population is. We are the ones that came up with this 5,000 based on the information they gave us, right? We doubled that initial amount. The population of the local high school might only be 10. Triple that would be 30. I'm going to divide. Maybe the population is only 1. What is triple that? 3. Or maybe the population is 1,000. Tripling that would give me 3,000. Any way you slice it, when I divide by that initial amount, I'm going to end up with 3 equals e to the power of 0.06 t. You guys understand how I'm using the 3 here? It has everything to do with this word right here. It does not matter what my initial amount is, when I divide by that initial amount, over on the left-hand side, I'm gonna get a 3. Yes, take it. 6A, yes. All right, for number 6, part A. This right here would be e to the 5x times this would be e to the negative 4 equals e to the x squared. Set my paper down. What can I do right here? I can combine those. What do I do with the powers when the bases are being multiplied? Add those together. So I'm going to add a 5x and a negative 4. So this becomes e to the 5x minus 4. I could natural log both sides, but what else do you notice? Yeah, I have e on both sides. So I can just cancel that out and ignore it. X squared equals 5x minus 4. You know where to take it from there? Okay. I have posted the entire solutions key. Make sure that I actually have that up. I have not posted it yet. I will post it before the end of the day today. I thought I had that up already. My apologies. I will also have the individual answers typed out in addition to having the solution sheet. So you can text up the answer, and if you didn't get the answer correct, you can go in and look at my work there. All right. I will have that up probably by about lunchtime today.